All right, well we're back today with something a little bit different, but kind of the same, right? We've done a little bit of math reviews here and there on this channel. Obviously, some math is incorporated into some of our engineering stuff, so why not review it? And then even more, I have a friend who's actually in a electrical engineering program, and he's doing some calculus, and he said today he was working on the quotient rule. So I just wanted to share a little trick that goes on in mathematics for remembering the quotient rule. So the quotient rule just has to do with doing derivatives, and it's basically when you have to divide two derivatives, when you have two functions like this that are being divided, and you have to take the derivative of them, of this whole function here. So what we do with this, what the quotient rule states, is that we would do f prime of x times gx minus f of x g prime of x all over gx squared. Okay, now that's the quotient rule. But obviously there's a lot of things to remember in math, and especially in math classes where you're learning a lot of stuff, a lot of new things, and it might be hard for you to remember that. So there's a memory aid that people often use, and it's called low d high minus high d low. For the numerator and for the denominator, it's just low low. Low low means low is multiplied by itself, meaning that it's squared. So low low, you just repeat the denominator twice. Okay, now what are these things? Low d high, high d ho. Is it's like we're singing some kind of country song or something? Not quite. All it has to do with is basically our functions and how they're oriented in the problem. So low, that just means your denominator. D high means we're going to take the derivative of the one that's higher up, right? So the one in the numerator, essentially. So this is taking the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So if we did that in this problem, we end up, let me just give you a forewarning here that quotient rules tend to be pretty long problems, so this will run a lot of page length when you're doing them. So the first thing is, if I do it this way, so I do low first, then we're going to take the derivative of, or d high, right, or the numerator. So the derivative of 3x squared is going to give us 6x. That's going to be plus 5. Then we're going to say minus high, which is just our original numerator statement. And then we're just going to say d low, so the derivative of the denominator, which is just going to be 1. So then we put this all under there, and low, which is just our g of x squared. All right, so now we have our statement, and then this is going to get a little bit longer because we even have to factor all this. So we're going to factor I'm going to do this over here, and I'll come up with a simplified fraction or simplified factorization, but I'm going to work on this right here. Okay, so we have x times 6x, so we'll have 6x squared This is going to be plus 5x minus 24x minus 20. Okay, as we can see, we have some like terms here, so we can simplify this to 6x squared minus 19x minus 20. So that's our statement for the numerator, so we can write this in here. And then here, this is just multiplied by itself, but with this, remember that we have to distribute this 1, or this negative 1, this imaginary negative 1 here. We're going to have to distribute all that. So this is going to become negative 3x squared minus 5x plus 2. And then we're going to try to simplify this again and see if we have any like terms. We've got one right here, and we should have one right here. Okay, and yeah, we have them right here too. So we'll do all those. 6 minus 3, that's just going to give us 3. X squared, negative 19 minus 5x is going to give us negative 24x, and then we have negative 20 plus 2 is going to give us negative 18. Now the numerator is all simplified, and if we saw that there was a reason to simplify the denominator, we would do so. In this problem, we can see that this x minus 4 squared is just going to give us x minus 16 if we do that, if we factored it, which isn't going to simplify with any of these terms. So there's no reason for us to go any further. So this is our final answer. That's how you use the low D high, high D low, low low memory aid to do some derivatives using the quotient rule. Thanks for watching.